Hello guys and welcome back. So now I'm going to load in the the collision geometry, which is this guy. As you can see, it's a low-res mesh. It should be enough for the collision that we need. And then this is the SDF, and you can see it's much more low-res than the one we created. And these are the previous caches. And for the source, I haven't written it to disk, so we can use the live one. That's fine. I'm gonna set this color to white. Okay, and let's make sure it has the velocity vector. Cool. And let's create our particle sim. I'm actually gonna reuse this one. And then for the collision, I'm gonna create a null. Let's say out collision geo. And then for this one, collision SDF. Okay, I'm going to create an object merge just to copy the path. I'm going to drag and drop that, and then let's dive inside and create a static object. Sop path, it's a deforming geometry. We need to turn that on. And then under the collision, we're going to change this to volume sample, and we need to load that the VDB or SDF, yeah, this guy. So if let's connect this. I'm going to create a ground as well. And let's go back to the first frame. Cool. And I added a transform here to scale the scene down because it was pretty big, so I'm gonna add the same transform to the object, to the source as well. This is just so that the noise values are more reasonable when it's at this scale. I prefer to use something bigger generally for the RBD because Bullet likes something 10 meters or higher, so it's very important to do that. And then for these sims, I'm going to scale everything by 10 times. Cool, let's align this. And we can preview the collision, make sure everything is fine. As you can see, all looks good. I'm going to hide the geometry for now so it's easier to see. And let's hit play. And that's our particle sim. Cool, let's go back and turn the guide off. I don't want to see the guide. I'm gonna add a color node. I'm gonna change it to ramp, and let's keep the default settings. And I'm gonna add some noise, tweak the noise a bit. Set this to 1, 1, and let's add another layer. This to 0.22, and in the inherent velocity I'm going to lower this to 0.05, and in the jitter birth, as you can see, the objects are creating gaps, and we have to tell it to use the velocity to jitter birth based on the velocity. I'm going to change this to this one to back and use point velocity, and hopefully that will improve the gaps between the objects. Yeah, it's working. And these two objects, I mean, this long trail I really like to fix in the sim, but for now we're gonna have to work with it as it is. Okay. Let's lower the life expectancy to 2. I don't want the trails to live for too long. And I'm going to change them to die when they collide. So under the pop solver collision behavior, I'm gonna take on the add hit attribute, and I'm gonna change them to maybe stick. Let's stick them for now and see what's gonna happen. So right now they're gonna stick to the geometry they will collide with, which may not be exactly what we need. Let's see what happens. So here it's going to emit a lot of points, as you can see. Cool. So I'm going to lower the gravity. I think it's too strong. I'm going to lower the gravity. I'm going to leave this as it is in case. Actually, I'm going to turn this off. I don't need any collision. I'm going to just lower the bounciness between the ground plane and also the object. So under physical 0.1. And let's see, I'm gonna go at the upper level, dub import. I want to import the points. Let's new pop object 1. Pop object, that's good. I'm gonna change this to fetch geometry from dots, and we want the geometry data. And this is going to import our particles. Very cool. So one thing I'd like to do is to be able to visualize this, I'd like to create a velocity based preview like we did in week 4. So let's do that. Let's create a point VOP, and let's call this val color by velocity. And this is going to help us visualize this a lot better. So let's compute the length of the velocity. Do a fit range. And let's expose the min and max and create a color. A ramp. And let's connect this. And I'd like to use some tones of blue, like the flip fluid visualizer. I'm going to set this to have a blue tone. It's blue. Something like that. And then this guy is a darker blue. And let's play with the colors, so maybe 0 to 10, 0 to 3. And I'm gonna increase the cache to 15 or 20. I want to cache the sim here. As you can see, it's really fast to interact with all this collision geometry and handle all the complexity basically, and it's still going really fast, and the memory is also very low at the moment. So let's pause this, and what I'm going to do is I'm going to display that low-res unpacked geo from SDF, the one we used for the collision. And let's change the background to dark. Turn off this, and let's play with this a bit more. Something like that. And let's set this to 2. Much better. Cool. So I'm gonna do a preview. I'll pause and we'll continue once this is done. Let it run for 120 frames. Hello and welcome back. So this is the sim. I think it's at frame 100 at the moment, and as you can see, it's working pretty well. Everything that we isolated is emitting the particles, and it's interacting with the geometry, and you can see that we don't have any emission in the front parts of any of the RBD, which is very, very important in these scenarios. Now, as you can see, there is a huge amount of dust falling off, but it's only being affected by that noise and turbulence that we added in the solver. In theory, all this should be affected by an area field, and we should get a lot more interaction. For example, as this object falls through, it should disturb that and create some more curly motion around around those particles, and that can only be achieved using the smoke solver. And so we're gonna look into that when we create the smoke trails as well. So the next thing that I want to add is, as you can see, this sim is only for objects that are moving at certain speed because it uses the velocity. But there is also all this, as you can see, this part here. As soon as it starts falling, it should leave some trails behind it. So we can either use another velocity source and basically tell it to pick the object even if it's moving really at a small distance or a small threshold, and use that to emit a different kind of dust, and keep this only for the fast moving objects. But there is also another method in Houdini called the debris source, which is a solver that it's a subsolver that tracks the initial state of the geometry and builds a link between the objects. So in the first frame, it knows that all these pieces are at that position. Once they start separating, it starts colorizing them using different colors, and it also uses the velocity, so it depends on how fast they separate from each other. It's going to flag those faces and generate points, and this creates a very interesting emitter. Now I'm going to show you in the next video how we're going to build the emitter from the debris source in Houdini. Thank you guys for watching, and see you in the next video. Let's play this for one last time. Cool. Yeah, the interaction here is very, very cool. Alright, see you guys in the next video. Bye bye.